Okay, looks like the camera did flash. In any case, for this to be numerically less than 1/10, the denominator has to be at least 1500, meaning that this product, which comes out numerically to 10 delta, has to be at least 1425, so that delta has to be at least 1/10 of that, 142.5. We'll assume delta greater than about 140 kilograms per meter. Now let's go ahead and put 140 kilograms per meter into this expression, okay? Now T isn't all that big, but if this has numerical value 140, and this has numerical value 2, and this has numerical value 5, then I believe we get at least 1400 numerically here, where this mass is only numerically 75, so it doesn't add all that much. And when divided by m, we still have something that's probably pretty close to the natural log of T raised to the delta V naught over m. Well, if T is 5, the natural log of 5, well, the natural log of E, that's 2.7 something, 2.71828, 1828, and other stuff. The square of that's like 7.3, okay? So 5 is between 2.7 and 7.3, probably a little more than the geometric mean between those. So T, natural log of T would be 1.6 or 1.7. Now, if the natural log of T was 2, then raising to this power, which would be 140 times 2 over 75, which would be 4. 2 to the 4th power would be 16. But 1.6 or 1.7 to the 4th power would be somewhat less than that, probably more around 10 or a little more. So that multiplying by m over delta, we have like 10 here, m over delta would be 1/2 numerically, and half of 10 would be 5. So just doing a few calculations in our heads, we can figure that delta around 140 kilograms per meter is not unreasonable, okay? Now this leads us, if you recall what we did previously, to a force at 1 meter per second of about 140 newtons, giving us an energy output of about 140 watts. Okay, and I said that, well, it takes 200 watts to make me feel the way I do when I move for 30 seconds at this speed, 1 meter per second. So we have pretty good evidence that at this speed at least, the drag coefficient of around 140 might be appropriate. Now, the reason I come to a stop is because at some point I come back to a drag coefficient that's proportional to V, not to V squared. Okay? So I do come to rest. If it stayed at V squared, I would never come to rest, and there would be no limit to how far I go. But that's not going to be the case. So there's some combination, some point in velocity at which I maybe fairly rapidly transition from a V squared proportionality to a V proportionality. So you understand that this question could get reasonably complicated. In any case, we seem to have, just based on what I know about my physiology and the wattage that it takes to make me suck wind, seems to be pretty good evidence that by the time we get up to 1 meter per second, I'm creating a lot of vortices, and I'm into the realm where my drag coefficient is proportional to V, or my drag is proportional to the square of V.